Okay, good evening everyone. So the problem I'm going to be reviewing is number 2 on Dr. Choi's 2016 practice exam. The solutions are already up there, but I want to provide some more depth into how one goes about solving the problem because I got a lot of questions concerning this. So this is the SLR algorithm that we're going to be implementing on page 31 of Dr. Choi's notes, and this is parsing from the bottom up. So what we did for problem 1 in the practice exam and what you did on homework 6 was top-down parsing with the predictive parser. Now we're going to be doing bottom-up parsing with the SLR algorithm, where we're going to end up constructing an LR, a collection of sets for LR0 for this new grammar. So grammar we have, if you go back to looking at the exam, 2016 second solutions, and then look, we have a grammar defined in terms of G equal to non-terminals, terminals, the start production rule, and then the production rule is P, the start symbol. So the non-terminals are S prime, S, and A. The terminals are lowercase a, b, and c. The start symbol is S prime, and the set of production rules P are shown. So what we do first is we're going to write down the production rules that we have. And although it doesn't require you to calculate a first and follow table in the problem, you have to calculate a first and follow table to allow you to properly calculate your reductions in the construction of the collection of sets for the LR0 grammar when you do the parsing actions. So before we keep going, remember we're looking at the algorithm on page 31 of Dr. Choi's notes. But the first thing we're going to do is construct our first and follow tables for these production rules. So if we remember, as before, when we look at a production rule, we're looking at the very first element of each production rule that's a terminal. So S prime goes to S, that's a non-terminal. S here goes to S, non-terminal. S goes to S, non-terminal. S goes to empty string. And that's it. So that means the only terminal in the first of S prime is empty string. For S, applies the same way because we have S going to S, S going to S. Those are both calling the production rule again. But here we have S going to empty string, another empty string in first. And then for A, it goes to C. That's a terminal, so the first of C is a terminal. To do the follow, we're going to imply our same follow algorithm that we talked about last week, where we have the S prime, because this would be implying rule 2, where A is S prime. And this rule 2, I'm forgetting the page it's on, but if you go back in Dr. Choi's notes, you'll see the calculation of follow. I believe it is on page, I'm looking at her notes now, just so you know what I'm talking about, but I think you do. It is on page, just one moment. What is it? Give me a second. I'm looking at another monitor at the moment. Let me just look it up. Sorry. It is on all the way back on page 27. So on page 27, Dr. Choi's notes, that's where you see the follow algorithm. So if you look at the follow algorithm, and then you see that because S prime goes to S, that would mean that we are having state 3 where there's no terminal, there's no beta after S. So that means that follow of A is an element of follow of B, So that means we have follow of S prime is an element of follow of S. I wrote it all out for the others, but S going to S, A, lowercase a, uppercase A, B. Here we have A, B is S, beta is A, capital A, B. So that's rule 2 of the computing follow. So that means that A, the first of beta, is an element of the follow of S. And S in this case is B. So we get that rule, A is an element of follow of S. Then we shift B to be under the non-terminal A. Alpha is the string SA. B is the non-terminal A. Beta is the string after A. In this case, beta is just made up of B, a terminal. This is also rule 2 of computing follow, where B is an element of the follow of A, because B is the first element of beta, and B is under A. Then we have the third production rule, S goes to S, B, capital A, lowercase a. A is under S, B is under S, beta is B, A, capital A, lowercase a. This is also rule 2, where the first of beta is B, so we have B is an element of the follow of S because uppercase B is S. And then we shift B to be under capital A. Alpha is SB, capital B is A, and beta is the string after A, which in this case is just A. Sorry, uppercase. It's confusing because there's lower and uppercase, but I want to make sure you're clear on this. Computing follow is important for all these problems. So we have A, which is the first of beta, is an element of the follow of B. In this case, B is the non-terminal A. So A is an element of follow, lowercase a is an element of follow of A. So we fill all this in. So we have also rule 1, we can't forget from computing follow, is that $ is an element of follow of the first production rule or the start state production rule S prime. So we put $ there. I do the ones on the left first. So A is an element of follow of S. Here we go. B is an element of follow of A. B is an element of follow of S. A is an element of follow of A. This A, capital A, lowercase a. And then finally, follow of S prime is an element of follow of S. The follow of S prime is $. So that means that the follow of S now also has a $. So now we're done getting our first and follow table. So now we can go all the way back to bottom up parsing. I should have written these numbers down, which I believe is on page 31. So that's follow, and that's SLR. So for that, we're going to have the set of a collection of sets here, where we're going to start by defining all the production rules. Well, we start really with I0. So how you build this is a little complicated, but it's the most important part of the problem. So we start with our very first production rule, our production rule that has the start symbol, S prime. S prime, and it goes to, and we can label this as set I0. We're going to have a collection of these sets, I0 through IN. And then we put S1 goes to, and we put a pointer at the very beginning of the production rule. We call it the dot, or the pointer, whatever we want to say. Call it pointer. The pointer before S. And then the next part of filling this out is if you have a pointer before a non-terminal, which is S. S is a variable, which is a non-terminal. We use those interchangeably. Then you can see everything, you can add all the production rules that S goes to into this set. So S goes to S A uppercase AB, S goes to S B uppercase A, and S also goes to empty string. So we're going to put all of those in here, and we're going to put the pointers at the front of them. And then we're going to analyze these production rules with the pointers in them for this collection, this set. And what we see is that we have the first element, which is our go-tos. In fact, I did this a little out of order. Usually you end up calculating the go-tos last, So ignore that for now. So the very first thing we're going to do is we're going to look at these three components of part 2 of the algorithm constructing an SLR parsing table on page 31 of Dr. Choi's notes. And we're going to see here that S going to empty string is equivalent to C in 2 of algorithm constructing an SLR parsing table, where if S prime goes to S pointer, where the pointer is the very end of the production rule, then you're going to set the action of the set number, which is 0, and the element A, which is a little confusing because we don't know actually what this is yet. We're going to determine it in a moment. This is why we need our first and follow tables. So we just know that we've got set. So all these, remember, this I through n, those are our sets, and we have numbers for those sets. So we have set 0 here. So we're setting the action 0 in accordance with rule 2b in the page 31 notes for Dr. Choi's class. And we're setting the action 0. We don't know what the non-terminal is, and we're going to have it reduced to S goes to where, and if you look at the algorithm, it says reduce A goes to alpha. And in this case, our A goes to alpha, S is our A, and alpha is our empty string. So we're going to put S goes to empty string at this position, 0 something. And the way we would determine where that position is we look at the follow table that we've already calculated for this particular non-terminal. So for this non-terminal S, we see in our follow table we have A, B, and $sign. So that means we're going to put this action, reduce S goes to empty string, which we can also write as R as R3, because we've labeled our production rules with numbers up here. That's where the shorthand comes in later, 0, 1, 2, 3, 4. So we could potentially label this reduction as R3, which we'll get to when we actually fill out the table. But for now, just keep track of reducing S goes to empty string. And we're going to set that at 0A, 0B, and $sign, because A, B, and $sign are in the follow of the non-terminal on the left-hand side of this production rule, which is S. So we've done that. Now we have to say, what happens when we read this S value here to create our next element in our set? So when the pointer reads over S, we create a new element in the set, a new set element, which we're going to refer to as I1. And here what we have is we have S prime still going to S, but now the pointer's on the other side of S. And we also have this S where the pointer's on the other side of S, and also here where the pointer's on the other side of S. So now we have 3 production rules. Just count this little dot here. This is where the pointer is. Sorry for the smudginess. This pen is, it smears a lot. So pointer's now on this side of S, as you can see. And what we're going to do now is do our analysis again, going back to page 31, constructing an SLR parse table. Number 2, the state I constructed, yada yada. We're going to look at A, B, and C here. So the first thing we see is S prime goes to S dot. This falls directly into C of those 3 options. And what that means is we're going to set the action 1, because we're in set 1. We're going to set action 1 at $sign, because C says if S prime goes to S dot is in set I of I, then set action I $sign equal to accept. So in this case, I is 1, $sign is still $sign, and we're setting that action to accept. So we've taken care of this part. Now we look down and we say, here we have S going to S dot A, and that's going to fall into part A of our 3 options on page 31, where we have alpha, which is S, we have A, some terminal, and then we have beta behind it. In this case, A is A, I know this is confusing, but if you're following along with page 31, you'll see what I'm referencing when I'm talking about A, alpha A, and B. So make sure you have page 31 open on Dr. Choi's notes, and you're looking at that while you're watching me. So we have S going to S dot A, capital A, B, and we're setting the action, because we're in set 1 to 1, we're looking at non-terminal A, and we're setting that to shift 2. And why we're setting it to shift 2, we don't know yet. That's why I put a dollar sign. I put a question mark here. We haven't created the shift state yet. So you kind of want to make a note that you're going to go back and fill this out after we create the next set. So we've done that, and now we can go down and create our next set. Here it is, set 2. So we have set 2 here. And set 2 is the product. This has been already exhausted. The pointer's gotten to the end of this production rule. But set 2, we're going to be looking now at this production rule here, where initially we had this S going to S dot A, capital A, B. And we're going to shift that dot over and create S going to S, lowercase a, dot, uppercase A, B. Now we've done that. We've shifted the pointer to the other side of A, but now the pointer is sitting in front of another non-terminal. And every time we have a pointer sitting in front of another non-terminal, we have to add that production rule to this specific set. So now we look, it's A, so we know A goes to C, so we add A goes to C in this set, but now the pointer is at the front again, in front of C. We also know, because we went from I1 to I2, that our shift for reading an A when you're at 1 is to 2. So now we know that that's equal to 2 because we've gone to 2. So from here, reading an A went to here. So that's all this set action IA to shift is saying. I know you've seen it's a 3 there. We haven't gotten to that yet, but I'm trying to keep it covered up. So yeah, you haven't seen this yet either. Just use your imagination. So you haven't seen that, and you haven't seen... This blocking is hard. You haven't seen that either. There you go. So now we're at I2, and we do the same thing again, where we look at S, set action, and an easy one we can look at is for 2, and for C, we're going to have to do some form of a shift. We don't know what that shift is yet because we haven't created that set yet. But we know that when you read a 2, when you're at 2 and you read a C, you're going to have to go to some other set because this is a terminal. That's the general thing you should be picking up here. Every time we're going from one set to another by reading a terminal, there's some shifting going on. And then we also have to deal with the fact that we have a go-to here because we have a non-terminal A, and we don't know what these values are either because we just know that at 2, when we read A, we also have to go to some new production rule. We haven't created it yet. So finally now, we create 3. And 3, I3, is a product of, now we have, so product rule 3 is we're going all the way back to I1. So that's why it's very important as you fill this in to remember what we haven't discovered yet and what we haven't created yet. So S goes to S dot B A, uppercase A, lowercase a. And now we're going to read the non-terminal B, and we're going to create a new set, I3 here, where S goes to SB after being read, now pointer, capital A, lowercase a. So now what we've learned is when we shift from 1, with a B, we go to 3. So now we have 1B is shift 3. And then what we do is so we've discovered that, take that off, so now we know go to IB3. And then also we're going to look and we're going to see what actions we can analyze from this. So one action we can analyze is that we have S going to S B dot capital A. Well, I did this one first because it's easier. So here's A going to dot C, and we don't know where this is going to yet. And what that means is that A, when you read A and it goes to dot C, we have some value. It's a terminal value. C is a terminal value, so we're going to have to create some other set that deals with where we go to with C. So we don't know what that is yet. So now we create another terminal value. Sorry, we create another set, S, going to S A uppercase A dot B. And we're creating this set with the pointer in this position because of being at I2 when we had S A dot capital A B and we hadn't read A yet. The order that these are being created in is by literally going through each production rule that we create. So not each production rule we create. I'm trying to make sure I keep consistent with my terminology. Each set that we make, within it, we're going through each production rule and we're checking, do we have to create a new set, and making sure that we go in order of the possible production rules in that set when we create new sets. So this is a result of going back to I2 and reading A, and now the pointer being on the other side of A, which means we finally now know that when you read an A at I2, you go to 4. Don't know what that is. You see it, but you're getting the idea. I'm running out of things to block. So you get a 4. And what that means is we can have this 4 here. So we've learned about it. And what we're then going to do is say S. So we filled this part in. Now we're going back down to I4. And what are we analyzing about it? We're analyzing that set action 4, when you read a B, is going to go to some new production rule that we don't know about yet. And what that means is that we're going to have some set action here. We don't know where it's going yet because we haven't created that set yet, but we know that when you read a B, you have to go somewhere. So now we have A going to C. So we don't know, so we're creating this from going back to I2, and this is for after you read C. So I5 is A goes to C after you read C, the pointer's on the other side of C. So now we know, go back to I2, from a 2C, you go to 5. So from 2, when you read a C, you go to 5. And I wrote that as shift as well. So when you read a 2, you go to C. When you read a C at 2, you go to 5. We can also analyze A going to C. So this is set action 5. We don't know what we're doing here, but we know it's a reduction, because if we go back to page 31 of Dr. Choi's notes and we see when your pointer is at the end of the string alpha, we're going to set the set number, we're going to set an action at the set number and at some terminal values to reduce A goes to C. And the terminals we're going to stick it at are the follow values of this production rule. So the follow values of production rule A are A and B. So that means we're going to set action 5, A and B, because A's follows A and B. We're going to set 5 at A and B to reduce A goes to C. So now we create another production rule. S goes to SBA dot. And this is now going back to I3. We've already figured out, we filled in everything from I2. We still don't know some stuff from I3. You got to work with me on this. You know, you can see what the final numbers are going to be, but when you're actually doing this the first time, you're going to be filling this in as you create these set values. So now at I6, we have S going to SBA dot A. This is coming from I3, where we've read the non-terminal A, the pointer's now on the other side of it, we've created a new set number, and we can analyze it. So we can see that we're going to set action 6. When you read an A, it's going to go to some shift value. We don't know what it is yet. This is all coming from A. If you go to 31 to A, this is when you have A going to alpha dot A beta. So these are all where you have this B non-terminal followed by a dot and then the alpha string, the beta string afterwards. So we don't know what that is yet. So we do know, however, if we go back to I3, that because we created 5, that when you read a C, you can shift to I5. So both I2 and I3 are utilizing I5 because they're both reading these same .Cs. So you have 2C goes to I5 here, and you have 3C goes to 5 here. We don't know about 7 yet. You can see 7. We haven't created 7 yet. Anyway, so I'm going to stop with the blocking because it just gets in the way. You're going to have to fill it out as you go, but I think you'll understand what I'm talking about when we get to it. So don't worry about the parse table yet, though. So imagine that we still don't know what that 7 is. And we're creating 7 by going back to, we've already taken care of I3, now we're at I4. S goes to SA, capital A dot B. Now we've read the B. So we already know that we've created I7, S goes to S, lowercase a, uppercase B pointer. So we can fill in now, when you're at 4, you read a B, that means you shift to 7, because this is the reading of the B. We can also analyze it, and we can see that this is also going to be a reduction because the pointer's at the end of this string alpha. So we're going to set action 7. We're going to look at this. We're going to look at this production rule S. We're going to look at. I'm going to cover this up just so you can see both simultaneously. We're going to look at the follow table of S, and we're going to see that S's follow table is A, B, and $sign. So that means at 7, A, B, and $sign, we're going to reduce to the production rule S going to S, A, capital A, B. Whoops, you don't want to see that. That's a stack. So then what we're going to do is we are going to look at, so we've taken care of I4. And then I5 we already took care of. I6 is coming here when we're going to create I8, because now we have S goes to S, B, A, capital A, lowercase a dot, or pointer. S goes to, I6 is S goes to S, B, capital A, pointer A. So reading an A goes from I6 to I8. So we can fill this in now. We know that we set the action 6A to shift 8, because when you read an A at I6, when you read an A, you go from I6 to I8. So we have that. So now we filled in everything for I6. We know where the shift is. Go-tos and shifts here are equivalent. I wrote both out, but you'll see what is necessary when I actually fill in the parse table. So we have to analyze now I8. So this is going to be another reduction because we have the pointer at the end and a string before it. So now we're going to look at 8, and we're going to fill in. We don't know what these values are, but we know that we have production rule S. We're going to look at the follow table of S, and what do you know? It's the same as what we just did. A, B, $sign is in the follow table, follow grid pointer box of S. So that means at A, B, and $sign, we're going to put the reduction rule, but it's a different production rule this time, remember. It's S goes to S, B, capital A, lowercase a. The first one was S goes to S, lowercase a, capital A, B. These are different. And that has to do with the fact that these two production rules are different. Because remember, if you look at B of 2, you go to page 31 of Dr. Choi's notes, you look at 2, and you look at B, it's stating if A goes to alpha dot. So in this case, this is our A, this is our alpha. In this case, this is our A, this is our alpha. So we've got all the information. So 2 pages, but we've got it all. Now we're going to fill in our parse table. So here's our parse table. Our information doesn't quite fit, but we can go step by step. So fold this out of the way so you don't worry about it for the time being. And here we go. So here we go. We have the state. Don't worry, that doesn't matter. The action, not a go-to. We have the action. We have the go-to. We have our terminals, A, B, C, $sign. And we have our non-terminals, S prime, S, and A. And at I0, we've learned that hold on one moment. At I0, we've learned that S prime goes to dot. So we've learned all this information. The important part, though, is we need to translate it into our parse table. So our first thing is we have our reductions. So we need to set a reduction at A, B, and $sign. So we do that. We're putting reduction 3, R3, at all of these. This is our R3, remember. S going to empty string. And we also have a goto here. We have a goto 0, S goes to 1. So whenever you have a reductions, you're going to fill in something on the goto side for the most part. Well, actually, that's not true. Discount what I just said there. But you're filling in your reductions, and you're also filling in S, because to go from 0 to, so you use a non, so the key is we're transitioning here with a non-terminal transition. So it's not reading a terminal, it's reading a non-terminal. So when you read a non-terminal, you have to fill it in on the goto. So we are reading a non-terminal S, and we're going from 0 to 1. So we're writing a 1 here. So when you're 0, you read a non-terminal S, you go to set 1. Now we go look at 1. And at 1, we have the shift at 1A goes to 2. So we put shift 2 at 1A. We have 1B. We have shift 3. So we put that here, shift 3 at 1B. And we also have set action $sign except. So at $sign we put except. Then for 2, we have, I really hope you can see everything I've written. For 2, you have at 2C, we have shift 5. And then also, because remember here, this is a transition on a non-terminal A, we have go to 2A, we're going to go to set 4, set number 4. So here at A, non-terminal A, when we're at state 2, we're going to go to state 4. Now we look at 3. At 3, we have set action 3C, shift 5, put that there. We also have a transition on a non-terminal A here, so 3A, non-terminal transition going to 6, so A, we put a 6 here. 4, we have just a shift, we have 4B, shift 7, put that there. 5, we have reduction, 5A and 5B. We're going to reduce AC. AC is rule number 4. Remember, rule 4, we can write it as 4 instead to save room. So we can write reduction 4 at 5, because we have set action reduction at 5A and at 5B. Then we go to 6. 6 is just at 6A, we shift to 8, so we put a shift 8 here. At 7, we have S. We have another reduction. We have reduction. We've set action 7 at A, B, and $sign to reduce. S goes to S, A, lowercase a, capital A, lowercase b. That is production rule 1. If you go remember production rule 1 here that we've labeled. So you put our production 1 here, here, and here for the A, the B, and the $sign. And then for 8, we have the same thing. Well, not, it's close, but we have set A, action A, and we have A, B, and $sign, because those are from the follow table. We already calculated that. It's earlier in the video, but we put reduce R2 here because we have S going to S, B, A, capital A, and lowercase a, and that's production rule 2, if you remember that. So now we filled in our table. We can get rid of this other stuff and just go directly to the parsing. So we've got our table, we've got our stack, and this is a little different, guys, than the predictive parser, so please pay attention. So we start off with 0. 0 is the number corresponding to our production rule. I'm going to leave this here because this is useful to look at the production rules. So we've got our numbered production rules. So we have 0, which corresponds to S prime goes to S. It's our very first production rule. So 0b, we look at 0b is a reduction, R3. And what R3 is S goes to empty string. So here our S is going to go to empty string. That means that the the, oh, sorry, hold on. So S goes to empty string essentially means that the production rule is a little complicated. So even though it reads S goes to empty string, we look at it almost in reverse. It means that where there once was an empty string in the stack, we're going to replace that with S. So there was empty string here, now we're going to replace it with S. So bottom-up parsing is a little bit counterintuitive because it builds from the bottom up. So we kind of have to get to the bottom first to build back up. But the point is, so we had an empty string here, and now it's being replaced by S. Then what we do is we look back, we look at the number before the non-terminal, 0, and we look at 0S, and we go back to our predictive parser, and we see 0 and S, we go to 1. So we add a 1 in front. That process is very important, so I'm going to repeat it. We had empty string, 0B, we were going to reduce S goes to empty string. That means we're going to place an S now in the stack, and to get the next number that we need, we're going to look behind S, and we're going to look at our state 0 at S, and we're going to get a 1, and we're going to put a 1 here. Then we look back at the input. 1 looks at B. That's easy. 1, B, shift 3. What shift 3 means is we move the B to the stack, and then we put the 3 in front of the B. So now this B that was on this side of the input is now on the stack, and there's a 3 in front of it. Then 3C, we have 3C, that's S5, shift 5. So we move the C onto the stack, and we put the 5 in front of it. Now we have 5A. So 5A is reduce 4. 4 is A goes to C. And that means that we have A goes to C, so we had a C here. We replace that C, so the number just goes away. The 5 goes away. It's irrelevant at this point. It was used for getting the reduce, and we replace the C with an A, and we look back then at 3. We look at 3A, and we get the number for the state 6. We have the 6 now. Then we look at 6A input, 6A, we have 6A, shift 8. Shift 8 means that we have the A that was here, now goes here, and then the 8 goes in front of it. Now we have 8A. 8A we see is reduce 2. Reduce 2 is S goes to S, B, capital A, A. And what this does is because, as you will see here, we're disregarding the numbers. They're sort of, they're kind of, they're just the states that we're using. So they're a construct for the parser to work, but they're not actually terminals or non-terminals. That's what we care about. So you'll see in reverse we have A, capital A, B, S. We're going to replace that S, B, A with S. So all that goes away, and now we are just left with 0S. And then we go look back at 0S, we get a 1, we put the 1 in front of it. Now 1A. 1A, shift 2, we put the A here, then we put the 2 in front of that A. 2C, shift 5, so 2C, shift 5. We put the A, sorry, we put the C here, put the C here, then the 5 in front of it from the shift, then 5B, so 5B is reduce 4. So reduce 4, if we remember, is A goes to C. So we're going to replace this C with a non-terminal A. Get rid of the 5. We have A. And remember now, whenever we do reduction, we have to do this looking back in the stack, which is a little confusing. But A looks back at 2. We see at state 2, at A, we have a 4. So we put a 4 here. Then we do 4B, the input, 4B, 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 shift 7. So we put the B here, put the 7 here, $7. Look at $7 is reduce 1. We have this S goes to S, lowercase a, capital A, B. You'll see again, disregarding the numbers, but we see non-terminal S, terminal A, non-terminal A, terminal B. We're going to replace that with S. So we're just left with 0S. 0S. We look back, because it was a reduction, we see 0, 0, S, 1. We put a 1 here. $1. We have $1 except, strings and except. And remember, what's going on here at this except is really S prime going to S dot. Because that was rule C, page 31 Dr. Choi's notes, 2C. That's what the except was referring to. So we've done that. We've completed all the parsing. To create the parse table, how you do it is you look at your actions, and because we're building from the bottom up, we're actually going to look at the actions in reverse. So the way it worked is we had S prime goes to S, then S goes to S, A, capital A, B. So S goes to capital S, A, capital, lowercase a, capital A, B. A goes to C. So it's going, instead of, we're so used to going from bottom left, kind of going, exhausting left, leaves, and moving right. In this case, we're kind of going from top right down to bottom left instead of from left up to right. So I know it's confusing, but when you read it in reverse, you see the parse tree built from the top down. So S prime going to S, S going to S, A, capital A, B, then A goes to C, so we're looking right to left. Then we look S goes to S, B, capital A, lowercase a, so this S goes to S, B, capital A, lowercase a. This A goes to C, so this terminal A goes to C, and this first, which is actually the very bottom, leave here, S going to empty string. So that's how you make your parse table. You read your actions in reverse, and then you map them out going from right to left. I hope this was helpful. Ask me any more questions you have about the exam. If you want a review for problem 1 on this, I didn't have time to make a video explaining that. It's an easier version of the problem you guys did for homework 6. I think you're going to do great. Follow this video. Send me any questions you might have. Have a good night.